Welcome to the 17th of our series of presentations under the ESAB University banner for specialty alloys. Today I'm joined by my colleague Simon Marks, who is a European product marketing manager for the products that he's going to be presenting. First off, I'm going to present storage and handling recommendations for consumables. So I'll be starting that in a couple of minutes. I want to say that the presentation has been recorded and everything is available on YouTube should you wish to watch it again. And if there's anything in here that you want to take note of, then please, my contact details are at the end of the presentation. Please feel free to contact me, get in touch, and I'm more than happy to send you a copy of the slides. And there's also a catalogue as well that we can send you with all of the information in it. So let's make a start. My presentation will last probably around about 15 minutes, and Simon's will last around about 10 minutes, so 30 minutes total. So I hope it won't take up too much of your day. So what's the reason for storage and handling recommendations? What are we trying to achieve? Well, everything's to do with quality. Everything's to do with the quality of the welds. So what are the reasons for doing what we do? And we'll take in turn the storage and handling of covered electrodes in ordinary packets, for want of a better description, and then the vac packs, the electrodes supplied in vac packs. Then we'll go on to solid wires, which are obviously less of a problem, but still we should take note and still should take care. Then on to cord wires and then fluxes. Some of probably the more obvious ones where you need caution. So quality, what's this all about? So the main worry with any kind of filler metal is dirt and water. If you get dirt and water in the weld, then that's a source of gas. As soon as the arc hits it, you're going to be creating gas. Gas creates pockets within the molten metal, so you end up with porosity. And then a particularly nasty type of porosity we can see there is a wormhole. So this is a big amount of gas or a big amount of dirt. So the gas, it can originate from the shielding gas. If the shielding gas is not correct, not set correctly, it's a wrong size nozzle for the amount of gas that you're putting through, or even the gas has got moisture in it, which I've seen several times. It's fairly obvious that when you're welding, everything needs to be clean, rust-free, grease-free. Organic contaminants like that are probably some of the main sources of the problem. And additionally, damp electrodes. So not just dirt, but they don't want to be wet, and the workpiece that you're welding doesn't want to be wet, unless you're welding underwater. But that's another whole host of problems that we can talk about in another presentation. So what we're trying to achieve, we're trying to achieve nice, clean welds with nice, clean filler metal. So hydrogen is a source of cracking. Hydrogen is created, it can be from the base metal. If the base metal is particularly dirty, contains hydrogen, moisture and grease. So the moisture will break down and create hydrogen gas. Hydrogen gas is it's certainly a contributor to cracking in the welds or the heat affected zone. So to get rid of the chance of moisture, then that's why preheat procedures and post-weld heat treatment procedures are absolutely recommended to be adhered to. So, talking specifically about covered electrodes, stick electrodes, MMA, however you want to describe it, I think everybody's probably aware that they can be supplied in various different sorts of packaging. So a shrink wrap paper box. The thing is, it's not completely airtight. So the flux that's coating the core wire of an electrode basically wants to gain moisture. It wants to take in as much moisture as it can. That's why we have to keep it covered up. So a shrink wrap box isn't airtight, won't keep out the moisture. Plastic capsules with a lid and tape, it's still possible. These are not airtight, so if air's getting through, then moisture will get through too. So obviously you can see on the right hand side we've got a drying oven and a heated quiver, so it's essential to keep these things dry, to take the moisture out of the flux. If there's any doubt, then re-dry it. If there's any doubt that it's been open too long, then re-dry it. They're the recommendations. If the electrodes are stored under correct conditions, and by this we've got a temperature range and a relative humidity point there, if they're stored within this, these are about as good as you can get to reduce the amount of moisture pickup. Obviously in temperatures, in very, very low temperature levels, it's good to maintain at least the storage temperature of 10 degrees above the outside temperature. If you're taking a very, very cold pack out of a store that's very, very cold, then it needs to acclimatize. It needs to reach ambient temperature before you open it. If there's a big difference in the temperatures, then it will encourage moisture. Moisture will form, and that's not a good thing. So another recommendation, we've got it in bold letters there. If electrodes are stored under described conditions, they can be kept for a maximum of 3 years. So that's what we're saying, a covered electrode has a shelf life of 3 years. In terms of re-drying, low hydrogen basic electrodes should be re-dried. And if ever there's an application, a process, a procedure that relates to hydrogen content in the weld metal, or there's a radiographic inspection, then it's very important that you would re-dry those electrodes before use. Acid rutile, stainless electrodes, and all type of basic electrodes will absorb moisture, but re-drying them restores their use. They're usable again. So they will pick up moisture, but once they're re-dried, they're absolutely usable again. Mild steel rutile acid generally don't need re-drying. It's not that important, and cellulose must not be dried. They like it to be wet. It's just the chemical composition of the flux that they use. Anything that's been seriously damaged, submerged in water for any period of time, it can't really be restored. Then the damage to the flux will be too great, and it's too risky even to try re-drying. It's important that every manufacturer puts instructions for re-drying, the temperature and the holding time. It's all printed on the package, so it's absolutely vital that those instructions are followed. That's why the manufacturers put them there. So into what is the re-drying temperature? It's the re-drying time is measured from when the temperature has been reached. So you can't just put it in a cold oven for whatever, 200 degrees, 250 degrees for 2 hours. It has to reach the 250 degrees, and that's when the time starts. That's the re-drying time. Quite important that you don't overload electrodes in a drying oven, not more than 4 layers. And also we recommend that you don't re-dry an electrode more than 3 times. So careful stock keeping and record keeping of what's happened to a pack of electrodes is quite important. Covered electrodes supplied in backpacks, you see it's an excellent photo there with a tropical fish swimming around a backpack. So these are, as the name suggests, packed in a vacuum. So they're hermetically sealed, packed in a vacuum. There's no air in there. As a result of that, you don't need to rebake, you don't need to put them in a holding oven, you don't need to put them in a heated quiver. They can be used straight from the pack without any need to rebake. As long as the pack's not been broken, the seal's not been broken, then you can use them straight from the pack. And we say you've got 12 hours basically. If you open a vac pack, then you have 12 hours to use them before they would need redrying. And it would also be the same for hermetically sealed tin cans, which is another method of supply. You've got to be careful when using a vac pack that you don't want to damage. If you're using the outer packaging, you don't want to damage the vac pack when doing so. Otherwise, you're going to get air in, and that's the 12 hours starts then. Take one out at a time. There's no need to get a handful of electrodes scattered over the bench. Just use one at a time, leave the rest in the pack. That will reduce the amount of time and the exposure to moisture that can get into the electrode. The design of most vac packs are very, very similar. So there's a space here to actually write the date and the time of opening. So the 12 hours starts then. You've got all the product data, probably with welding parameters for the various positions, and it will also have the redrying times, should these be on more than 12 hours. They're also kept within a plastic box. It's not just a foil wrapper. There's a plastic box in there that can be resealed to keep as much moisture out as possible. So onto solid wires. Do we really need to bother about solid wires? Solid strip, big mag T, submerged arc. Well, yes is the answer. They should always be stored in dry conditions. Again, you do not need moisture. You don't need condensation on the wire. You don't want to be trying to weld with condensation on the wire. So wherever possible, keep it in the original packaging, unopened. And again, if it's particularly cold in the storeroom, then when you bring it into the shop, leave it to get to ambient temperature before you open it. And again, you'll try and keep as much moisture out. Obviously, it's the same with any welding. Contaminants should be avoided as much as possible. Most spools these days are supplied in plastic bags, and it's best to keep it in the bag for as long as possible. TIG rods, again, keep everything clean. It's repeating the obvious, really. Everything needs to be kept very clean, away from dust, dirt, oil, grease, and moisture. The TIG rods that ESAB supply are in a rigid fibre tube that's PE coated, so it's got very good moisture protection, but still care needs to be taken to ensure that there's no moisture on the wires. The marathon packs or bulk packs, they're obviously designed for bulk usage, usually with robots. So every one of those is got VCI paper inside, so it's got the anti-rust paper. So it's good for keeping the moisture out during transport. But again, if at all possible, the storage conditions want to be a minimum of 15 degrees. Again, you don't want a massive temperature difference because it would encourage moisture to form on the wires. So 15 degrees with a humidity of, it's a relative humidity of 60%, if at all possible. Aluminium is a particular point in question. It's a little bit different. It needs more care and attention. Obviously, it needs to be clean. But aluminium that comes into contact with water, then it eventually forms this hydrated oxide coating. That will break down and cause break down under the arc, under the heat of the arc, and it will form hydrogen gas. Hydrogen gas, as we said, is a creator, a cause of porosity in the weld metal. So uniformity of ambient metal temperatures is even more important in aluminium. Electrode and the base metal should be allowed to stabilize to the weld area temperature. Again, acetate cleaning is strongly recommended for aluminium. So cleanliness is the key with aluminium, with another added difficulty about temperature, maintaining the ambient temperature, the relative temperature of the wire and the workpiece. The strip, pretty much the same rules as for solid wires. Keep everything clean, free from contaminants. Strip is obviously only used for cladding, surfacing. It's never used for joining. So relatively speaking, it's not as important, but you still don't want contaminants and porosity in there. It's still very possible to get porosity in a weld cladding, so care has to be taken. Cord wires, obviously these contain flux or metal powders. So it's a tube, it's a tiny tube that contains a flux or a metal powder. The non-alloy and low alloy core wires are not really susceptible to moisture absorption. The chemistry, the type of materials that we use are not really susceptible, where stainless grades really are. And these grades are packed in vacuum packed in foil pouches for that reason. So obviously you don't want to damage the foil pouch. That's when the time will start, and that's when the moisture can start to get into the wire. It's essential that while they're in use for a minimum amount of time as possible, they shouldn't be left on the machine out of the stores when they're not in use. They need to be returned in the packaging as much as possible and put back into the stores. Condensation can cause an awful lot of problems with flux cord and stainless cord wires if they're given the opportunity to get to the moisture. It's good practice if a machine's been left for a couple of hours to run the first couple of layers off of the spool, because that wire will have been open to the atmosphere. You may get some oxidation on there, so it's a source of hydrogen again for the weld. So generally all cord wire should avoid direct contact with water, and again, it's good practice. Keep everything clean as possible. Cord wires that are rusty, this is in big letters, cord wires that are rusty or have had serious water contamination or have been left out for a long period of time, they cannot be restored and they need to be scrapped. To be safe, they need to be scrapped. Strip cladding fluxes, submerged arc welding. The fluxes, when they leave the factory, are all guaranteed to have a moisture content as manufactured. That's how they're manufactured. That's what we try and achieve. So pallets are shrink wrapped in plastic foil to maintain that as manufactured moisture content for as long as possible. But unopened bags should be stored in temperatures around about 20 degrees. And again, with a relative humidity around about 60%. The block packs and the aluminium lined 25 kilo bags or big bags and the 25 kilo steel buckets, they can be, as long as they've not been opened, they can be stored under severe conditions for as long as they remain unopened. So these things are they're vacuum packed, they're lined with aluminium, or they're hermetically sealed, so they're going to stay moisture free for as long as they're closed. Worth knowing. Once a flux has been opened, then any unused, any opened fluxes and unused content in a flux hopper that you're cleaning out, it's got to be dried before use again at around about 150. Recycling is obviously common with large submerged arc welding jobs, so it's essential that the compressed air that you use to recycle is clean, moisture free and clean. That's the last thing that you need, is to have moisture and oil from your compressed air. When you're recycling, you must have at least 1 part new to 3 parts recycled. So you've got to keep topping it up in there. And again, once if it's gone even more, it has picked up moisture, then use the correct equipment that either stirs the flux or shallow trays. The drying cycle is around about 300 degrees for 2 to 4 hours. So in summary, I've taken 20 minutes, sorry Simon. All the details that I've presented today are available in this brochure, Storage and Handling Recommendations for Filler Metals. It's a new brochure that's been published this year by ESAB. Like I say, if anyone wants to get in contact with me, I'll happy to send a copy. So thanks very much. We'll look at the questions after Simon's finished. Simon, over to you.
Good afternoon, I'm Simon Marks. I'm just going to briefly talk to you about the chemical range that we offer within ESAB Europe. So you can see on the screen here, we offer anti-spatters for weld surfaces. Also available are the anti-spatter for weld surfaces in drums, just below. Then we go a step further and we offer anti-spatter for tip protection. So ESAB, TBI and TBIO. We have a steel preparation chemicals, stain flux and stain clean. We also offer surface cleaning for aluminium and steel, called Arc-Air Protex. And also, along with our anti-spatters tip protection, we offer nozzle and tip protectors as well, obviously TBI and Arc-Air branded. So on that screen, you can see our full chemicals offering from the weld surfaces to the front end of the torch protection to the preparation of the steel before welding. Okay. To take it one step further, our anti-spatters, we offer 3 ranges: Ecotech, High-Tech and Aristo Fluid, and the differentiation between the 3 of them is the working temperatures. So the Ecotech has a working temperature of up to 100 degrees, the High-Tech is a working temperature of 150 degrees, and the Aristo Fluid is a working temperature of 200. They have the same characteristics as you can see, and these are aerosols formulated to work for the weld surfaces, but can also be used to apply for nozzles and contact tips as well. As I mentioned just at the start, we offer the same anti-spatters in Arc-Air branded. So the Arc-Air Protex Plus, which you can see from the photos before and after, if you use it with and without, spatter is designed to provide a safe working environment for the welder. This also comes in aerosol cans. Easy to use, non-toxic, protects the surfaces as well. The Arc-Air Protex Extra, which you can see from the bottom, with and without, is a liquid that provides easy to apply anti-spatter protection for surfaces, tools for welding and gouging by creating a protective layer. Okay. As I've mentioned as well, the anti-spatter fluid for the workpiece and for tip protection come in larger drums. So where you have customers that are using it on their own procedures, they can buy Aristo Fluid Advanced, TBI Tip Clean and TBI Anti-Spatter in big drums over 25 litres. So as I mentioned, tip protection. ESAB, we offer a product called Jig and Tool Protector. It has recently got a new and improved chemical composition. This is a ceramic coating that is sprayed on the front end consumables to help protect against spatter during MIG welding. This recipe is classed as its best in class. It has excellent separating effect, silicone and water free, suitable for painting and galvanizing of the workpiece, and offers high productivity and increases the life of your front end consumables on your torches. That being said, we offer the same in our TBI Classic and our TBI Cera Protect range as well. Following on, talking about protecting the front end of the consumables, TBI Tip Dip. TBI Tip Dip forms a thin film around the gas nozzle, which effectively prevents adhesion and corrosion of welded spatter. If used regularly, it will increase the lifetime of your nozzles as well. So it can and does lead to increased productivity. Same again for the Protex tip dip at the bottom. You can see a photo of a front end nozzle, obviously used with and without our protection, and you can see the corrosion that's done once it's used without using our protection. Still treatment chemicals, 3 steps, 3 chemicals: stain flux, stain clean, and stain wash. Stain flux is applied to the root side before welding to protect against oxidization. Stain clean, pickling paste, cleans and passivates welding joints and the heat affected zone, used on welding stainless steel. It leaves a clean finish for the weld area. Stain wash is used directly on the steel surfaces to neutralize the inhibits stain clean pickling paste after uses. It is mildly contains alkaline and contains no toxic constituents as well. So you can see on that screen, preparation for the chemicals. You have 3 products to fit all the needs. Aluminium and steel treatment chemicals. Protex Ali Clean. This provides rapid and effortless cleaning and removal of grease, oil, dirt and white chalky aluminium oxides before welding. So this is giving you the best start for preparing your workpiece before you start welding. Okay, when you're cleaning uncontaminated welds are a must on aluminium or stainless steel afterwards to protect it. So that's principally the chemical range. We will have a new brochure that will be distributed around shortly, which highlights what I've just talked about in the presentations as well, and also gives you a bit more scientific information about why you should use it and why you shouldn't use it. So that's a brief introduction to our chemical range for you. If there are any questions, do please let us know, and you have my contact details there as well.
Thank you, Simon. Yeah, I can see one question for you and one for me so far. The one for you is the anti-spatter chemical different for stainless steel as it is for low alloy? And I must admit, I don't know.
What was the question again, Peter?
Is it the same chemical that's used for stainless steel welding and low alloy steel welding for anti-spatter? Is it the same chemical?
It is the same chemical, yes.
Well, that was easy. Thank you for that.
It is the same chemical, yes, it is.
Fantastic. Right. We've got someone saying, how long can filler metals, or should filler metals be kept as a maximum? And I think I did mention that. We recommend 3 years. 3 years. You should look to have used it by then. So that's kind of our. It's a generic kind of recommendation. 3 years. Here's another one. We have to weld in sub-zero temperatures. What precautions can we take? Blimey. Welding in sub-zero, there's a whole host of problems that you've got, not just your storage of your filler metals, isn't there? We mentioned that I assume it's not aluminium. Welding aluminium in sub-zero temperatures would be really difficult to get good welds. It's important that the filler metals are warmed up. You can't take them out of a you can't take the filler metals out of a very, very cold store and then start to use them in warmer temperatures. Or if they're taken out of a cold store and used in very cold temperatures, then you've got a whole host of problems of things like thermal shock. You have to be really careful with the preheat temperature, for example. So even if something wouldn't normally need preheating, if you're going to weld anything of any size, then you would absolutely need to do some preheat in there. So please, if you can give me some more specifics, you can send me an email. I'm happy to look at a specific case. It's a tricky one, really. Just saying sub-zero, it's what you weld in and how much and for how long are all the issues that you need to take into consideration. What's the differences between MMA redrying procedure for stainless and low alloy rods? So right, yeah. So for MMA electrodes, what are the differences between drying a stainless MMA rod and a low alloy MMA rod? And really, the every manufacturer has their own recommendations, so it's important that you follow the recommendations that are written on the packet. The ESAB have got their own recommendations, but if you're not using ESAB filler metals, then you really should just follow the recommendations that's written on the packet. Okay. But another one, what determines the shelf life of an electrode? What should be expected after redrying the same electrode for a few times? We said that you shouldn't redry it more than 3 times, and that's really because you're going to be affecting the composition and the microstructure of the flux itself. The flux coating is going to change. It changes slightly. You're going to be losing some elements in a microscopic scale, but things are going to change just by nature of them being retaining moisture and then being heated up. So things change a little bit, and that's why we say a maximum of 3 times. Once it's been done 3 times, then really you should either use it or throw it away. Another question is the recommended humidity maximum 60% and temperature minimum 10% 10 degrees for solid wires. What are the recommendations for flux cord wires? Again, each manufacturer has their own set of recommendations, but relative humidity at 60% and a temperature minimum of 10%, that would work for flux cord wires as well. So there are no more questions. We've just taken over 30 minutes. So thank you very much, everyone, for listening. I hope it's been useful. Stress again, please don't hesitate to get in contact with either myself or Simon directly if you have any further questions, if anything we've not answered, and if you want any of the notes or a copy of the slides. Thank you very much, and everyone have a good weekend. Thank you.